Hi everyone. We're going to be talking about the prime counting function, which is a worked example for 1D lists. So the prime counting function is the function counting the number of prime numbers less than or equal to some real number, according to Wikipedia. So we're going to be computing this answer in two different ways. The first will be using the Sieve of Aristophanes. So to go over it really quickly again, the sieve basically has an is-prime list that assumes that all numbers are prime, and then we just set 0 and 1 to be false, or not prime, and then we loop through all of the numbers from 0 to n plus 1 because we want to include n in our prime count. And if that entry is true, then we know it's a prime number, so we add it into a list called primes, and then we go through, and for every multiple of that number, we change the entry in the is prime list to be false, because we know that that number has a factor that is not 1 or itself, because its factor is that prime number that we just found. And then at the very end, we return the prime list. And so then, to find the prime counting function answer, we just find the length of this list, because that contains all of the prime numbers that we found, and so length will just tell us how many there are. Also, we can perform the same operation in a different way. So basically we can use is prime to look at all of the numbers from 0 to n, including n, and we just see if that number is prime using our traditional is prime function. And if it is, we increase our prime count by 1, and at the very end we return the prime count. So we see that here we're just comparing the answers that we get, and we see that no matter which method we use, we get the same answer. But the more interesting thing is when we time them. So we're going to count the number of prime numbers less than or equal to 1,000, and we're going to see how long it takes during each method. So we'll run this. Okay, so we found that there are 168 prime numbers that are less than or equal to 1,000, and we see that it took is prime method set 0.75 seconds, and it took the sieve method 0.2 seconds. So it's a pretty big difference, actually. And we see that the ratio is about 3.6. So I will leave it to you as an exercise to figure out the big O of these two functions and figure out why the sieve is so much faster. But it's pretty interesting.